Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to do a couple more examples, or at least one more example of solving differential equations, the systems of differential equations using differential operators. And annihilation. So again, the first thing is I've given you a system of differential equations, and I need to write this in differential operator format so then I can do some annihilation. So let's rewrite this. This is going to be equal to, well, this is dx is going to be equal to 4x plus 7y, and over here I have dy is equal to x minus 2y. Now what I want to do is I want to put everything on the left hand side so I can have the right hand side equal to 0. So this is going to be equal to dx minus 4x minus 7y is equal to 0. And similar, this is going to be equal to, well, I'd like the x's to come first. So this is going to be negative x. And then I have a plus dy plus 2y is equal to 0. So let's just make sure that that's good. 4 became negative, 7 became negative because it's sent it over. This dy is already on the left, so when I put that over, it's going to be negative, and when I put this over, it's going to be positive. Fantastic. Okay, so now what I want to do is I want to pull out the common function. So from this, so this is d minus 4 of x, and then similar, this is going to be d plus 2 of y. So what we're going to have is the system of equations is going to be d minus 4 operating on x minus 7y is equal to 0. And then very similar, I'm going to have this minus x, and we're going to have the differential operator of d plus 2 on y is equal to 0. Now I'm trying to line up the x's and line up the y's so then we can know what we have to do in order to annihilate, say, one of the variables. So let's go after the x. So if this is a d minus 4x, I need this to have a d minus 4 in front of it as well, and then they would be opposite in sign. So I'm going to do the differential operator of a d minus 4. Remember, we have to do that to everything, d minus 4. D plus 2 y, and this is also going to be a d minus 4 acting on 0, and my claim is that this is 0. So remember, this would be the derivative of 0 minus 4 times 0, so this clearly is going to be 0. So that right hand side is 0. And then up here I have this, that d minus 4 operated on x minus, our 7y is equal to 0. Now that these are opposite in sign, I can now add them. I will do it over here because we're going to need the room. So what we're going to have is these will annihilate, but then it's going to be, I'm going to write the positive one first and the negative one second. So this is going to become, d minus 4 times d plus 2y minus 7y is equal to 0. So what I can do is I can pull out the y and then simplify this differential operator acting on this y. So this is going to be d squared minus 2d minus 8 minus 7 on y is equal to 0. Is that right? It sure is. So this is going to be equal to d squared minus 2d minus 15 acting on y. And again, remember that the zeros of the differential operator match the zeros of the characteristic equation. This is a d minus 5 and a d plus 3 acting on y. So I'm going to have zeros of 5 and negative 3. So y of t, our solutions, are going to be equal to a c1 e to the 5t plus c2 e to the minus 3t. Okay. Now I need to do the same thing for this, except instead of annihilating the x's, we need to annihilate the y's. So we have to ask, what do we have to operate on in order to get rid of these y's? So in order to do that, I need, well, this needs a 7, and this needs a d plus 2. So that's what we're going to do. I'm going to do the, I'm going to do a d plus 2 on this one. So this is going to be a d plus 2, d minus 4 acting on x, minus 7d plus 2. And of course, we explained that d plus 2 acting on 0 is going to derivative of 0, and then also 2 times 0, so this is going to be equal to 0. And then down here, which is what we really needed as well, is this has to have a 7. So this is going to be a negative 7x plus 7 times d, forget my y, d plus 2y is equal to 0. Now when I add these things, we can see that the y's will now cancel. So I'm going to have, over here, we're going to have a d plus 2, d minus 4 on x minus 7 on x is going to equal 0. So similarly, d plus 2, d minus 4, boy, is it the same? Sure is. Minus 7 on x is equal to 0. So we can see that we get this exact same equation. So what we're going to have is this is going to simplify to, d minus 5, d plus 3 on y is equal to 0. So I'm going to have the same solution here almost, except remember the coefficients are different. So x of t is going to be some c3 e to the 5t plus c4 e to the minus 3t. Now, again, our job is to, remember, it's supposed to only have 2 parameters, not 4. So we need to see if there's a relationship between the C1 and C3 and also the C2 and C4, and there likely will be. In order to verify that, we are going to pick one of our equations. It doesn't matter. In the previous one, I picked the top equation, but you could pick the bottom equation if you want to as well. Let's do that, because the bottom equation looks a little easier. So let's do the bottom instead. Now, if I'd leave it up to you. I'm going to pick the bottom. Maybe at home you pick the top and just verify that you get exactly the same relationship. So do we have the room? Let's write x of t down here. Maybe I squish this in. X of t is going to be the same thing. This is c3 though, e to the t, and then plus c4 e to the minus 3t. Ooh, barely got her in there. And I'm going to go after this equation and make that work. So we need the the derivative of y, which is going to be c1 e to the 5t plus c2 e to the minus 3t. And this better be equal to x, which is down here. We have this c3 e to the 5t plus c4 e to the minus 3t minus 2 times y, which is right here again. So this is c1 e to the 5t plus c2 e to the minus 3t. And I'll distribute, but I want to set this thing equal to 0, so then those coefficients can be equal to 0, and I can find the relationship between these coefficients. So the derivative of this is going to be, 5c1 e to the 5t minus 3c2 e to the minus 3t, and this is going to equal c3 e to the 5t minus c4 e to the minus 3t, and then distribute the negative 2. And then I'd like to set it equal to 0. So let's go ahead and send them over here. So 0 is going to equal. Now I'm gonna do, for this coefficient, I want the e to the 5t's. So we're going to have a c3, where's also e to the 5t. So this one, and then also this one. So this is going to be minus 2c1, and when I put this to the other side, this is going to become minus 5c1, and this will all be e to that 5t. Now with what's remaining, I'm going to do, your e to the negative 3t, so I got one here. So this coefficient minus 3c4, this coefficient minus 2c2, and then this coefficient, but I'm putting it on the right-hand side, so this is going to be plus 3c2 e to the minus 3t. And we can simplify these a little bit. Minus 2 minus 5 is minus 7, so c3 minus 7c1 e to the 5t, and then similar over here. These will combine, so minus 3c4 plus c2 to the minus 3t. And since exponentials are never 0, the only way that this equation is equal to 0 is if these coefficients are equal to 0. So that means that c3 is going to be equal to negative 7c1. And similarly, actually, that's not true. that coefficient has to be equal to 0, and then also this coefficient has to be equal to 0. That's better. Okay, so I'm going to solve this for C3. So C3 is going to be equal to 7C1, and I'll solve this one for, really I want to solve it for C4. I want to write everything as C1 and C2, so minus C4 is going to be equal to, minus C2, so then C4 is going to be equal to 1/3 C2. So finally I can set up my final system of equations that, x of t is going to have, it's C3 plus C4, but C3 is this, so this is 7C1 e to the 5t, and then plus C4, which is going to be minus 1/3 C2 e to the minus 3t. And then finally our y of t's already had the C1 and C2 in it, so this is C1 e to the 5t plus C2 e to the minus 3t. And another thing you might want to check is, verify these things indeed are solutions to not just this equation, but also this one as well. So again, if you plug those things back into this, you'll get this exact same relationship for C1 to C3 and also C2 to C4. So next time I'll do another one, maybe one that's slightly more complicated as well. And if you like it, please subscribe.